Alright, here's a tutorial for the solving systems of inequalities by graphing assignment. I'll work through the odd problems with you. Alrighty, so our first line, x less than 1, is a horizontal line. And it's going to be a, a dashed line on the positive 1 value of x. And the test point I'm going to use is 0, 0. So when I substitute 0 for x, 0 less than 1 is a true statement. So that means I'm going to shade everything on the left-hand side of that line. Now, y greater than or equal to negative 1 is a sorry, y'all. This is vertical, the first one. The y one is horizontal. And it's at negative 1. It's a solid line. So I can use 0, 0 again as my test point. So when I substitute 0 into the equation for y, I would have 0 greater than or equal to negative 1. That is very true. So that means I would shade above the red line where 0, 0 is. So the solution to the system is this region here where both shadings overlap. Number 3, I have a horizontal line where x is 2. It's going to be a solid line. I can use 0, 0 as a test point. Again, you might want to plot it and label it. So I would substitute 0 for x. 0 less than or equal to 2 is very true. So that means I would shade to the left where 0, 0 is. The second inequality, x greater than 4, is also I said horizontal again. It's also a vertical line, but this time at 4, and it's going to be dashed. Again, I can use 0, 0 as my test point. Plug in 0 for x. Oops. Is 0 greater than 4? No, it's not. So I'm going to shade in the opposite direction of where 0, 0 is. And in this case, that would be to the right of the red line. So since the two shadings do not overlap, this function has no solution. Or this system has no solution. All right, for number 5, I need to solve for y to graph the inequalities. So to cancel x out, I would have to subtract it to the other side. And then I would divide everything by -1, which would leave me with y is greater than or equal to. The sign changes when you divide by a negative. And then -1 divided by -1 is a positive 1x. And then positive 2 divided by a -1 is a -2. All right, so I would plot -2 as my y-intercept. And my slope is 1 over 1, up 1 over 1, up 1 over 1. And this is going to be a solid line because of the equal to bar. All right. Now I can use 0, 0 as my test point. Now using the original inequality, I'm going to replace 0 for x and for y. So I would have 0 minus 0 less than or equal to 2, which would give me 0 less than or equal to 2, and that is true. So that means I would shade above this blue line in the direction of 0, 0. For the second inequality, to cancel x out, again, I would have to subtract it to the other side. And then I would divide by positive 2, so it would be y is greater than or equal to. So my sign stays the same because I'm dividing by a positive, not a negative. And that's a -1 in front of x, so that's a -1 over 2x. And then it's a positive 1 divided by a positive 2, so that's a positive 1 over 2 for my y-intercept. So positive 1/2 is about here. And up 1, I'm sorry, down 1 over 2 puts me about here. And this again is a solid line. I can use 0, 0 as my test point again because the line doesn't cross through it. I'm replacing 0 for x and for y, so I would have 0 plus 0 greater than or equal to 1. So 0 greater than or equal to 1 is a false statement. So since it's false, I would shade everywhere 0, 0 is not. And in this case, that is everything above the red line. So the solution to this system is everything up here. All right, for number 7, they're already solved for y, so I just need to plot them. So the first inequality will have a y-intercept of -3. It has a slope of up positive 1, run 2. It's a solid line. All right, I can use 0, 0 as my test point. So plug in 0 for y and x. I will get 0 is greater than or equal to negative 3, which is true. So I would shade above this blue line in the direction of 0, 0. All right, the next inequality has a y-intercept of 0 and a slope of positive 2 over 1. So I can't use 0, 0 for this test point. This is a dashed line. So I have to find some other test point to use for the second inequality, as long as it's not on the line. So let's use 2, 1. So put 1 for y and 2 for x. So I would have 1 is less than or equal to 4, which is true. So I would shade to the below the red line. So the solution to this inequality is right in here. Number 9, again, is already ready to go. I just need to graph it. So I'm sure you can handle that one on your own. Let's look at number 11. I will help you write it in slope-intercept form, and then you're on your own. So I would cancel out x by subtracting, then divide everything by 3, and you would end up getting y is less than negative 1 over 3x plus 1. On the second inequality, you would subtract x again, then divide by negative 2. So you would have a y is less than or equal to, because again, the sign flips when you divide by a negative. And then it's negative 1 divided by negative 2, so that's positive half x. And then a positive 4 divided by negative 2 is a negative 2. So there you go. Now finish graphing the system and find the solution region. Number 13, we have a word problem and we have to write the system and then graph the system. The most Kayla can spend on hot dogs and buns for her cookout is $35. A package of 10 hot dogs costs $3.50. A package of buns costs $2.50 and contains 8 buns. She needs to buy at least 40 hot dogs and 40 buns. Write a system of inequalities that represent this situation, then graph. All right, so the most she can spend is $35. That's the most, that's her cutoff. So I'm going to say we have H for hot dogs, or I'm sorry, the number of hot dogs, number of hot dog packages, and we're going to say B is the number of bun packages. So it's 350 per hot dog package plus 250 per bun package, and it cannot exceed $35. Then we need at least 40 hot dogs. So if H is a hot dog package, and there's 10 hot dogs in a package, that means we need at least 4 packages. So H has to be greater than or equal to 4. Again, it says 40 hot dogs and it's 10 in a package. So that means 4 packages. Does that make sense? All right, glad you're following. And then we need 40 buns, and there's 8 buns in a package. So that means we need at least 5 packages. So buns needs to be at least 5. So now let's graph the system. So let's say our x-axis represents our hot dog packages, and our y-axis represents our bun packages. Okay. I think it's perfectly fine to go by singles, but let's see what solving the first one for B. Well, no, let's just find the x and y intercept. So to take my first inequality and find the x-intercept, I would solve 350h less than 35 to get h by itself. So let's divide both sides by 350 and see what we get. All right, so 35 divided by 350 is 10. So the x-intercept is 10. So h has to be 10. I put 0. To find the y-intercept, we're going to solve 250b less than 35. So we're going to divide 35 by 250 now. 14. So my y-axis needs to get as large as 14. Let's see how many singles we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yeah, we have enough. I'll just count every two. And for my x-axis, I'm going to count every two as well. All right, so for our first inequality, let's plot the x-intercept. That was 10, which is here. H was less 10. And then B was 14. And then we just connect it with a line, a dashed line, because it said no more. And then for our test point, we could use 0, 0. So 0 less than 35 is true, so that means we would shade below that line. All right, H is going, since H represents our x-axis, that's a vertical line at 4, and it's solid. Again, I can use 0 to replace H with. 0 greater than 4, that's false. So that means I would shade everything to the right of this line. And B is greater than 5. That's a horizontal line and it's solid. I can use 0 again. 0 greater than 5 is false, so that means I would shade above the line. So the solution is where all three colors mix. So it's in this tiny triangle right, oh my goodness, right here. That's the solution to this system. I hope this tutorial is helpful. Good luck on finishing the rest.